Okay, for higher students only then. Oxidation numbers. Definition. These represent the charge of ions in a compound, or the charge of the ions within a bigger ion. Okay. There are certain rules here which we need to apply. In the exam, you'll be given a compound, or you'll be given a big ion, something like this, and you'll be asked to work out what the oxidation numbers of, say, chromium is in this ion, or iron in this compound. Okay? So to be able to work that out, we need to apply these rules. You won't need them all to work them out necessarily, but we'll need some. So oxygen in a compound. Wherever oxygen is in a compound, its oxidation number will always be 2 minus. Hydrogen in a compound will always be 1 plus. The oxidation numbers in a compound always add up to, so in a compound like this, a compound being 2 or more elements bonded together, always going to equal 0. So all the numbers add up to 0. Rule number 4, group 1 elements in compounds will have a 1 plus charge, and group 2 elements in compounds will have a 2 plus charge. Okay? But we know that anyway from the work that we did in C3. The oxidation numbers for an ion equal the charge on the ion. So that's a bit squished up. Number 6, the oxidation number of an element in its ground state. Now this is the bit that students often get confused. And we need to identify what an element in its ground state would be. So a metal by itself, so sodium solid, magnesium solid, hydrogen gas, nitrogen gas, oxygen, chlorine. Essentially, if we have a molecule with the atoms of an element bonded together, just one element bonded together, then it is the element in its ground state. Okay, there's no other elements in there, it's just nitrogen, just oxygen, just chlorine. Okay, so we applied those rules to work out the oxidation states for elements in these. Okay, so the first one here is hydrogen gas. It's a molecule, it's only bonded to itself. So therefore we can apply rule number 6. Oh sorry, I forgot to tell you, that's 0. Okay, so the oxidation number for an element in its ground state is going to be 0. So here, element in its ground state, its oxidation number for hydrogen is going to be 0. Fluorine, exactly the same applies, rule number 6, equals 0. It's an element in its ground state, just bonded to itself. Iron, here, as a solid, is also an element in its ground state. It's not bonded to anything else. Okay, so it's going to be 0. Now the rules change. This is a compound because there are 2 different elements bonded together. So 2 or more elements bonded together make a compound. Now here we can apply rule number 1 and rule number 2. So hydrogen will equal 1 plus, and oxygen will equal 2 minus. Okay. Now we also need to look at rule number 3. The oxidation numbers in a compound always add up to 0. So we need to check that this is the case. We've got 2 hydrogens, both have a 1 plus charge, and 1 oxygen with a 2 minus charge. So 1 plus, plus 1 plus, plus 2 minus is going to equal 0. Okay. Iron oxide, getting a bit more complicated now. It's a compound again, 2 different elements bonded together. We don't know what iron is in this case, but we do know what oxygen is, so we apply rule number 1. So we've got 3 lots of oxygen here, and they are all 2 minus. Okay, and we've got 2 lots of iron, Fe Fe2, yeah, O3, so we've got 3 of those, 2 lots of iron, and the whole thing needs to balance out to 0, okay, because it's a compound. So that goes back to rule number 3. So here we have 6 minuses, and we have to cancel out those 6 minuses with 2 lots of iron. So each one of these must be 3 plus. 6 pluses, 6 minuses equals 0. Okay, so the oxidation number for iron in this compound is going to be 3 plus. Last one, we have a complicated iron here. This is the chromate iron. So Cr2O7. So in this case, we can apply rule number 1. We know that oxygen in this ion will have an oxidation number of 2 minus. Okay, and we've got 7 of them. So we have got 1, 2, 3, 4, 5, 6, 7, which is 14 minuses altogether. Plus we've got 2 lots of chromium. Whatever their oxidation state is, it needs to cancel out most of that and leave us with an overall charge of 2 minus. Okay, so go back to rule number 5 here. The oxidation numbers on an ion add up to the charge on the ion. 2 minus charge on the ion, so overall the oxidation numbers add up to 2 minus. Okay, so we've got 14 minuses there, so we need 12 pluses between these two. So each of these is going to have to be 6 plus. So we've got 12 pluses, 14 minuses overall give us 2 minus. So here, the oxidation number for chromium is going to be 6 plus. Okay, so to summarise, oxidation numbers for higher students represent the charge of the ions in a compound or a complex ion. There are 5 rules to apply. Oxygen is always 2 minus, hydrogen is always 1 plus. The oxidation numbers in a compound add up to 0. Group 1 elements in compounds are 1 plus, and group 2 elements are 2 plus. Oxidation numbers in an ion always add up to the charge on the ion, and the oxidation number of an element in its ground state, so either by itself or bonded to another element, another of the same element, will always be 0. And then you will be asked to identify, for example, here, the oxidation state of ion and chromium in these compounds and ions. Okay? Take it on.